All right, hello. Good morning. Yeah, I say it every day. A good night's sleep does wonders. So we got completely stuck on this query thing yesterday. It didn't work the way I wanted to. Um, but just sitting down this morning, I often do that when I have my morning coffee. Kids are watching some TV, eating breakfast and stuff. Mm-hmm. We're that kind of family. They watch way too much TV, but it makes life so much simpler. So we do it. Um, yeah, and I was just playing because I was thinking about this going to bed yesterday. And then for some reason I just started coding, and then it just kind of resolved itself. So I started. So we're kind of in the middle of the change here. But before that, I wanted to talk about so we talked about like how is it different to embrace React? Like it's immutable, it has waterfall reconciliation, you use the update function to change state. And then we were talking about uh this single page perspective where the in this world the user hits a URL and you try to optimally fetch data and render UI specifically for exactly what the user wants, right? And often they just hit that single URL. And yeah, like it's a many things here, but that was like, okay, that was a perspective. And then we had this other perspective where it doesn't matter which URL you hit, you kind of have the full application. So you're not like jumping between pages, like traditionally jumping between pages, talking to the server. Um, Everything happens in the client, right? So you have a pure client-side router, and that creates like just an insanely snappy experience. But there is this other perspective that I think is more interesting, and explains it better. So when you're in this world, you have fused state UI. And here you have separate state UI. And how does this actually look? So if you think about your component tree, right? So you have this list of components. Actually, maybe we can just draw rectangles. So you have this component tree. And then in these components, you have like some of it is UI, some of it is state, right? So you have a single representation of state and UI, and it's called components, and they all live in a component tree within the reconciler. That's one mental model. And then you have separate state and UI. So you basically have two trees, right? You have one tree that is focused on UI. So when you dive through the components, it's like only presenting UI. They aren't concerned about anything else. And then you jump to this other implementation in your app, which is your state. And everything, all the nested stuff you read in the state is about state, right? And then this one stays like immutable. This one can be mutable. So React is still React. You just remove some complexity from React. And the way this kind of represents itself in my head, let's see. So you kind of have this graph here, I think. So this would be like component or UI complexity. And the thing is, when we talk about UI complexity, we think about the actual UI. We don't think about how state management is affected by that UI complexity. But that is the thing about React, because you define your state with your UI. More complex UI means more complex state management. And the way this goes is like, let's do like and I'm not sure what this line represents yet. We're going to talk about that. But like as UI complexity increases, there is like this, it just goes up and up and up. So here you might have only components, and then at some point you start, as the like state management of this UI increases, you start using hooks, and then you might lean to context, right? So this is how you manage it. But there is a point here where this just breaks. It just can't go any further. And that's not only, I had a very interesting conversation yesterday with a new colleague, Ernesto, and it was very like, even though it was quite concrete about something he was building, it was also quite philosophical, like how do we think about state management and stuff. It was just sharing our experiences. And often we talk about performance, right, when we talk about the external state management, but there is a more important factor, and that is maintainability. Because as this complexity, and you can imagine like UI, how should I, like UI complexity, component tree, like how do you like if a tree has many branches and many leaves, I guess size of tree, something like that. Oh, can I center this? I can. Size of component tree, right? That's the general thing, and then at some point it just starts burning. Not because well, part of it is performance. Like you the higher you get up here, the more in risk you are of performance issues. But the more difficult thing is maintainability, because now it's so difficult to navigate and find and figure out where to implement state, because you have this huge ass component tree. And some of it is UI, some of it is state, some of the state is in local components, some of it is in hooks, some of it is in context. Like it just becomes unwieldy. That's my point. And some point here, you get to that. Let's write about that. And risk performance issues, state all over. Yeah, I wish there was like a single way to, like this is the inflection point I'm talking about. Yeah, let's just call it unmaintainable. Some point here, it's unmaintainable. Yeah, maybe we should call this like maintenance burden. Like it's not only maintenance burden, it's also it's like not just maintenance of the code, it's maintenance of your mental model, like and navigation. Like it's everything that has to do with is there a single word for that? Like everything that has to do with, it's almost like things starts breaking down. Like it's the performance breaks down at some point, and navigating the code breaks down, your mental model of the app breaks down. Yeah, maybe we should just write those down. Breakdown. Let's just call it maintainability burden. We're gonna call it that. So there's a maintainability burden. Okay, so this is one way to build an app, and this has to do with, so and this ties into what kind of app you're building, right? Because if you think about React and server-side components, for example, the complexity is like encapsulated within each page, behind each URL, you have complexity. But a lot of apps isn't represented by that single endpoint the user hits, right? The URLs are more like just a way to represent certain states of a bigger UI. So you have, for example, a dashboard, right? And then the URL doesn't represent like a specific dashboard. It represents that, okay, on this dashboard, I have the following main menu element active. I have this tab open, and then I have something else within that tab open, for example. And the dashboard is like you navigate around it all the time. Yeah. Yeah, I'm not sure if that is a good explanation. I think I'm lacking experience with like other types of apps. I've only built these like rich client types of apps. And with success, like in terms of maintainability burden and the way I've experienced approaching things, we've been able to maintain it and we've been happy about it. And every time we try to embrace React, the maintainability burden has been unbearable for those kinds of apps. But defining them is very difficult because it's not about like you can build. So for example, a technical separation of it is like, okay, we mount up the full app in the client. It's client driven. We have a client router and like everything's in the client. But that's more a technical solution than what kind of app are you trying to build. So one aspect, a very simple aspect is like, for how long is a user going to be there, right? Is it like Google, or they like you go in, you search, and you drop out, you jump to a different page, right? Or are you going to stay hours inside this experience? But that doesn't make sense either, I think, because then you have something like Amazon, like a typical e-commerce. Like you could stay a long time inside an e-commerce experience. So that's not true either. Maybe it's like how personal it is. Like is the main, so that's an interesting thing. So for example, Code Sandbox, you're looking at your own dashboard, you're interacting inside your own sandbox. Something like Airbnb or Amazon or whatever, you are interacting with public entities mostly, right? And there are thousands of them. Unlike if you're interacting with your own dashboard, there's like a limited amount of data you're interacting with, and you're interacting more with it. Yeah, I don't know. I'm trying to figure that out. But at least this helps. And then there's a different way of building apps where it's almost like I just want to draw a line here like this. This is not very scientific, but this is like, what should we call this? Yeah, so you don't even have like different concepts. You just have state, right? So it's the maintainability burden here is like, how should I explain this? Okay, this is definitely not clear to me yet. But the point is that going into this world, you have an initial cost. And the initial cost is that you're maintaining two mental models, but they are separate, right? So when you work on state management, you work on state management. There's a clear mental model of state management, and your code reflects that mental model. And then you can work on UI, and there's a clear mental model of that. it's only elements and styling and stuff. But the cost is like you have to flip between them, right? So there's an initial cost there. I would argue it's very, very low, but there is a cost there. As opposed to React, you don't have that cost. You just start building components and you have your state management within those components. But then as complexity increases in React and you start applying more abstractions like hooks and context, and it grows and grows and grows, and it's like you can't see what components manage state and what manages UI, and you start getting performance issues, and then it just becomes unmaintainable at some point. But with the other solution, even though you have an initial higher cost, it scales endlessly. Like you could just scale and scale and scale and scale, and your React components will still only be concerned about elements and styling and any animations and stuff. And your state management layer will only be concerned about state management. Like, I guess it's unfair to say it's like endless, but it's like something like this or something. I don't know. And I want to say like this is much, much lower. Something like this is in my head. But the point isn't really these lines. The point is you choose. You embrace React. Okay, you only have your components now. And you have to do all your state management and all your UI mixed in those components. And to keep up with maintainability, you have to be very disciplined on how you scale your state management. As long as you use local component state for actual local component state, and you move to hooks as that complexity increases, you move to context when you want to share, and so on. But it's very, very difficult to have that discipline. And at some point it's gonna break anyways. While here you have an initial cost of 2 mental models. There aren't really 2 mental models either. There's 2 different layers. Well, it depends. Like if you use Mobx with classes, for example, it's 2 mental models and even 2 paradigms. So I think that's kind of the point I'm getting at here. It's like having these 2 maintainability cost, maybe? Cost? Maintainability. I don't know what to call this. But the point is like this Mobx reactive thing is about lowering the initial cost. Get it down here, right? And the way it does that is that instead of like introducing classes, which is a completely different paradigm than React, we're still just using functions. We're using the same patterns. It's just that we have functions that's not reconciling, and we have this reactive function instead. That's what I'm trying to do. Yeah, I'm not sure how to communicate this. But at least for the documentation, it should, like, it's fused state in UI or separate state in UI. Yeah. And this is what I mean about, like, if we move this around, let's just call this React state or UI, React state, something else. So what I mean here is like the true statement of React is this. This can be expressed as this, right? While here you can't express it like that because you have each component is, yeah, oh, I like this. So each component represents state UI kind of. And some of them might be context, some of them might be hooks. But here you have the mental model of like, okay, this is all your state. this is all your UI. It's almost like you think about your app as one big ass component. Yeah, there's something about this, because when we're introduced to React, we're introduced this very simple mental model of state. UI is a function of state. But in reality, you have hundreds of components in complex applications, and each of them is a state of UI. UI is a function of state. And the problem is, like, where the hell does that state come from? And it's really like props, a mix of props. Yeah, so it's not really true. Like, it's like props state, right? Because you don't only have local state, you also have state dependencies from your parent. And I guess that's what they mean. Like, when they say, they actually mean props. And then this concept of local component state, that came after, like, statements about these functions, UI as a function of state. That was before hooks came. So you kind of have props, really, and then internally you have state. But yeah, anyways. But this is not like, I don't think this technically necessarily resonates, but it does explain how your mental model shifts. Like, you have all your state in one place and you have UI in a different place. It's almost like each component acts as its own little application. Which you might think is a good idea. And maybe it is in low complexity environment. State maintainability. Yeah. Okay. I think that was enough ranting about this. I think we should write some code. Yeah. So I like these two statements: fused state UI, separate state UI, separate state from UI, fused state with UI. And then I like this illustration, only I'm not sure about these ones. If that really explains the thing. Yeah. And then, yeah, I have no idea if this really explains it. Like, I like this line. Or state maintainability burden. So you start with like one component, like it's not a maintainability issue, and you keep going. Yeah, and there's really nothing special here. There's no different concepts, unlike React, which has like these different ways of composing things. So you start with components, and then you start moving to hooks, and then you start moving to context, and then it just increases and increases and increases. And it increases with, it's not like you get to a point. Yeah, and there's also change friction. So when you fuse your state with UI, whenever you want to change the UI, it has friction with how you define your state. And when you want to change your state, it has friction with how you define your UI. So it's more rigid. While here, you can freely change your state. It will affect your UI, but they're not like, you don't have to refactor, how should I put it? Like they are literally closer together, so they have higher friction, right? So it's not that it's frictionless if you change your state here, because you have to go and change your UI, right? But there's less friction doing so, because you can move any component at any point in the component tree. You don't have to move your state because you moved your UI. Oh, you know what? I know the thing I'm thinking about. So the friction here, let's remove this one. I'm not sure about that one. But the friction here is, let's just make some points. So the friction here is two-way friction. So that means if you change your UI, there's a higher chance that you also have to fix your state, right? Because your state is fused with the UI. So moving a component because of UI changes affects the state. And the other way around. So if you change your state, it affects your UI. That's just by default. But here, there's only a one-way friction. Because the reason is that you can change your UI as much as you want. It doesn't affect your state at all, right? Because it's external. And you're just consuming your state, so you can just move components around freely. But of course, if you change your state, that's going to affect your UI, right? So that's a big point. Yeah, I wanted this to be... No, I think it's a good way to represent it. I just don't have like a good statement next to it. But that is how React works. Like every component is like potentially some piece of state, like it's its own little application. It's not like a dumb view layer, right? You need to introduce state somewhere. Not every component necessarily introduces state, but they can. So maybe we can do this instead. Yes. Let's see. Let's move this down and let's say state. Oh. The state React. Yeah, I like this. It's getting there. Okay, cool. No, let's write some code. I want to write some code. Okay, so the query thing. I had a hard time thinking about like what the public interface for this should be, and I made a discovery yesterday. I thought, because I implemented this, what's it called? Suspense thing with promises, And I thought they had removed it, but they haven't. So we can actually control promises and we can support suspense. So the point is that when you consume a query, you might want to consume the promise of that query because you're doing it in your external state management, or because you want to use the use hook inside React, right? And then you might want to just access the state itself, so you can check the status of the query. And then you want to be able to revalidate, and you want to like force fetch, right? But we want it to be lazy. And the way we can make it lazy now is that we make state and promise a getter. So whenever you access state or you access promise, and it hasn't, like internal state is idle, it's gonna fire off the thing. But what I discovered that I did wrong here is that I actually don't need this, I think. Sorry. So we're not gonna do this like blocking promise kind of thing. What we can do instead is, oops, sorry. So we're just gonna have this idle state. So let's think about this. So I have this internal state, it's idle, so it hasn't fetched anything yet. And the actual state of the query that we expose, that's also gonna be a getter return state. But if I access state now, I'm gonna check if in internal state is idle, we're just gonna go and fetch. And when I run that fetch is going to, it returns a promise, but it also updates the internal state. So that's something I kind of have to, that's something I know. Does it also, let's see. So when I execute the query, let's see, new internal state. Yeah, we need to fix that. Yeah, anyways, so what's going to happen here is that it's going to, when I run fetch, it will, well, actually it won't change the state initially, because that's the whole point, is that we want to stay in pending. It just kind of triggers the promise, right? But that does mean, didn't I say that? Oh yeah, sorry. This was the revelation for me. Like the promise isn't on the state anymore, right? This is the whole thing. So when I go and I ask for a promise, sorry, when I go and ask for the state, I can just fire up this fetch and then I can return the state safely. So that's gonna, it's still gonna be in pending. I'm returning the state and looking at status and whatever. And now the internal process is going to update that state. But if I get to a promise and I want to use the promise, then I can just return yes. Let's see. So this is gonna return the promise, but it also changes the internal state. So it currently here, it doesn't know that now the state has changed, but it has. How are we gonna express this? I think we kind of have to just tell it. This changes internal state to active. So we're going to say that this as active state, active internal state. We have the promise, so we know that. Cool. So this is basically what we're doing. So whenever we access state, if we're idle, go and fetch. And that's going to change the internal state, but it doesn't change this state until the promise starts resolving, right? So what we need to do is, first of all, we need to introduce the way we do. Let's see, impact. Impact React signals. Source. We're gonna bring over how I did the promise thing. So I was very happy when I saw that it can actually do this. Yeah, we need all of this. Let's see. Oh. Let's shove that down here. So we have observable promise. Yeah, I think we're gonna try just using it. Let's see how this will work. So let's imagine now that we are running fetch, and fetch is gonna run execute query. And then if our internal state is active, we're gonna abort. Then we're gonna create a new abort controller. And then we're gonna create let's see, observable promise, create observable promise. Let's see, what does it take? It takes the promise, which would be fetcher, and then it takes the abort controller, and then we have the promise. Let's see, so I think we can remove all of this. Yeah, let's just remove all of it and do it again. So now we're getting, so we have return status. Wait a minute, this is wrong. Return current active. We have the board controller. We have our promise. Oh, did we add the status? Okay, so we don't need the status here anymore. But it's gonna be an observable promise. Let's see, observable promise. Okay, this is really coming together now. And this is gonna be observable promise. So this is gonna be the observable promise. Oh yeah, T call. Yeah, this is gonna be great. And here in this callback, we're going to get the updated promise. So what we have to do here now is, I think we just have to do internal state. Yeah, like first of all, yeah, sorry. Yeah, this is the same thing. So okay, I think we just wonder if we should just, yeah, I think we have to cast it. So basically, internal state as active internal state promise equals promise. But, sorry, just a second. The challenge though is that when we're changing this, Yeah, I think set promise. I think we can do this. New promise. We're gonna check it. I think this is gonna internal state equals new promise. I think this is gonna handle observation. So if I have a getter and a setter, whenever I set this, it's gonna trigger observation on this one. I think so. We'll figure that out. Where was the execute query? Okay, so now I can actually say query state dot promise equals promise. And then what we have to do is okay. Interesting. Yeah, but this is actually quite correct. The only thing is that I'm calling this, let's call them pending. No, they have to be lowercase, actually. But that's fine. Can I do like do uppercase? Does that work? No. Yeah, because I want to have the convention of doing like uppercase on the states. Do uppercase. I think we can do this much better. So, but state now. Oh, come on. Is Twitch ban? Is Twitch, does it have like what's it called? Spammers? That sucks. Let's see. So we have this promise here. So we're going to look at the promise. So now the promise actually has a state of being fulfilled or not. So when it's fulfilled, we're going to update the state. Yeah, and now, oh, this is even better. Oh, nice. Because now we don't have to do that crazy thing anymore. Oh, nice. Yeah, this is definitely coming together now. I'm looking forward to playing with this. So we don't have to do this anymore. Now we can simply express this like we wanted to. Where am I? Okay, so if promise.status is fulfilled, we're gonna do query state.state, and we're just gonna replace it. That's perfectly fine. So this is gonna be status resolved, and then we're gonna get the value from promise.value, and then is revalidating is false, and then here we're gonna say rejected, and the error is promise.error. Reason, sorry. Oh, and reason here is unknown. We're gonna change that. We're gonna say error because it typically is an error. Reason error. Like theoretically, it could be something else than error, but it's not normal. Okay, this is. I think this is it, and this is much cleaner. So just to kind of go through it, the way this works is that we have this internal state, and this internal state is only there to represent if we actually started fetching already or not. That's the only reason it's there. And when we have an active internal state, which means that we've actually fetched something, It's going to be active, and it's going to hold the abort controller for the current promise and the promise itself, which is an observable promise, which means that we can use it with suspense. Let's rename that to suspense promise. Suspense promise. Yeah, suspense promise. And then we have the actual state that we expose. So when you look at a query, you have query.state, and then you have pending, or you have a status resolved with a value, or it's rejected with an error. And then you have the query itself, and it has a state, and the state you would typically use with React. So simply by like consuming the query and looking at the state, it's going to initialize the initial fetch if the internal state is idle. And the same goes for the promise. So you can consume the promise in a component, and you can use the use hook, and the promise is a getter, so it's gonna fire off the request or the fetch if the internal state is idle. But you can also use that promise in your state management, right? And you can use the state as well in your state management if you wanted to do that. When you call revalidate or fetch, revalidate is going to be a background thing. We're going to check those. But anyway, so when we call the query and we have the internal state of idle, we have the initial state of the query as pending. And then when we return the actual query state, let's see, query state, we have the getter as a send. So if the internal state is idle, we run fetch, and then we just return whatever the state is. Oh, wait a minute. This also needs to be a setter. Set state. Oh, this one's more tricky. How are we gonna do this? I think maybe we can just, yeah, I think it's fine to just do this actually. New state, state equals reactive new state. Yeah, I think this is fine. We're gonna try that. So whenever we try to get the state, we just make sure to trigger a fetch, and then we'll return the current state. And whenever we change that state, we're gonna completely replace the state with a new reactive state. And I think that's gonna trigger the getter. That's how Mobx works. We'll figure that out. And it's the same for the promise. If it's idle, it's gonna start a fetch and then just return the internal state promise. And then whenever we want to update that promise, we are going to just update it on the internal state. And again, this should trigger any observation of this promise. That's going to be interesting to see, because that might break our approach. And then we have revalidate and fetch. So let's look at, so fetch is fine. Like that should always just execute the query. But revalidate, that's different. Yeah, so we aren't handling revalidate correctly yet. So, well, sorry, we are, I think execute query is now, yeah, sorry. So revalidate works. So this is like just grabbing the promise in the background and then updating it. But when we're doing a fetch, we actually want to set query state dot state. We actually want to set that into pending. And so that will be the first thing we do. But also the internal state should immediately, yeah, but the internal state actually gets the, Oh yeah, sorry. So this actually returns the internal state, right? Yeah, you know what? So here we actually want to, where were we? So when we're fetching and we get this new internal state, we're actually going to say query state dot promise equals internal. So we're immediately going to update the promise, right? This is the whole point. And we can do a transaction around this. Oh, of course. Well, let's not do the transaction. It doesn't matter. So this is the difference between fetch and revalidate. On fetch, we're going to immediately set the query state to pending, and we're going to add the new promise that's currently like processing, right? And then in revalidate, we just simply don't do that. We are just going to return. We're just going to set the new internal state. But we are returning the new promise. But I think that's fine. Yeah, so when you actually call fetch, you want to have the promise of the actual fetch. And the same with revalidate. You want the actual promise of revalidating, right? But this other stuff that's being like observation based, you just don't want, you just don't want to update that when you're revalidating. So the exposed promise is stale. The exposed query state is stale, exactly like you wanted to. But as soon as that promise resolves, it starts updating the query state and the query promise. But internally, it already has that promise. Yeah, so another thing I think we need to do here, we need to say internal state. Oh, damn typing. We need to update the internal state promise as well. But it's just a typing thing. I know that we have this state. Yeah, let's just new state, new internal state, active internal state. And then we can actually point to it here. Yeah, let's just try this. I think we're ready to play with it. Let's build it. Like the mutation thing is much simpler. It's much simpler. Yeah, and then like another thing is like you shouldn't try to reinvent React Query, but the point is React Query isn't built for external state management, so we kind of have to reinvent it. Another thing that React Query does is it's called structural sharing. It's not really what we mean here. But when you fetch something and revalidate something, we don't want to like replace the value. We actually want to update the value, right? So if you have an array of to-dos and you get a new array of to-dos, we want to go through that new array of to-dos and update wherever necessary. Yeah, ship it. Yeah, so that's the final feature that needs to be there, is to update. The abort controller. Yeah, because now, yeah, so so the way this works now is that I'm creating an abort controller here. So if for some reason we execute the query again, that abort controller is going to be called here, like the old one. So this is not aborting the actual network request. This is aborting this callback so that it doesn't run this callback if you execute a new query. So it's just aborting like the promise. It's not aborting the actual HTTP request. Yeah, it's kind of like what, I don't know if you've seen examples in useEffect. You could also use an abort controller. Like if a component unmounts, you can, on the disposer of the effect, you can abort the abort controller, and then in like the then and the catch, you check the abort controller. It's kind of the same thing here. But yeah, okay, let's play with it. Yeah, I guess we should do something that's kind of relevant. Let's call it like to-dos. Export function to-dos. Oh, look at you, started to learn. Import reactive from Mobx. Reactive. Oh, isn't it called Mobx reactive here? I think I have to link it. There we go. Does it magically just work? Oh, I have to yarn link Mobx reactive. Oh, look at that. Yarn for library development. You are amazing. Okay, so what we want to do here, we want to try to use a reactive query instead. This is going to be a string array, I guess, for now. And then we need to like fetch to-dos. So let's do a function fetch to-dos. And we're just going to do new promise. Look at you. Huh? Okay, so that's going to be our query. I guess we don't care about the add and remove currently. We can explore the mutation there later. Okay, so we have some to-dos now. And in our app, let's do const to-dos. And then, yeah, we even have the thing there. Query, I guess. Yeah, maybe should even just call it query. Oh. Let's just call it query. To-dos query. So what we can try to do first is, I don't know, if query.state pending return. Let's do the traditional thing first. Loading. If, yeah, we can, like the typical thing is to like switch on the query status. Case. Oh, it had something. Oh, look at that. Yeah, yeah. Well, it don't need a default. It should be exhaustive. Yeah, that's basically it. Did it have any? Yeah. Okay, which port is this running on? 5175. Oh. So it didn't work. I wonder if it is my assumption about the setter. I think I know how to solve it though. I think Mobx has, I'm very confident it is the setter, but we can check. Let's see. So the point here is that we're running the actual thing now. So we accessed state console.log starting fetch, and then setting state. I don't think this is actually going to be, no, that doesn't make any sense. I'm very confident now. We have to change this. So Mobx has a different kind of primitive. That's not like an observable. That's not like an observable, but it's like kind of like a ref. That's what I want. Where is that thing? API observable.ref. Further information. But only reassignments will be tracked. Yeah, I'm gonna check that one. Let's see. Oh, I have to restart my computer. It's reactive.ref. Oh, sorry, not reactive.ref. Oh, yeah. Let's not use reactive here. Let's just use observable. So this is observable. Is it observable? That's what I use, right? Or was it make auto observable? Oh, it's make auto observable. And then I think there's an observable.ref. No, that's something else. That's not what I'm looking for. Though I think there is something that works like a signal, right? I can handle this by just using an observable, but create atom, is that the thing? Okay, no, I think it's simpler. Okay, let's just use reactive, and then we're just gonna change how we do it. So instead of having the state, we're gonna call it state ref. And then we're gonna say current. And this is only to trigger observation. So we have a state ref. This is gonna be state ref current. And then we're gonna say state ref current. And we don't need reactive here now. We should be fine. And this is fine. Well, not quite fine. This also needs to be observable. So it needs to point to some underlying. Okay, I think we're gonna. Okay, we're gonna call this state Yeah, we're going to call this state. I'm going to call this query, and then we're going to call it internal. And internal is going to look like that. Query. And internal state. Cool. And then we're going to remove, this one. And then we're going to say state.internal state.query state.query. Good morning. Oh, can't you see? Wait, what's happening here? Wait, are you stuck on the browser? Wait, what's happening here? Hey. Oh, wait, the whole screen is, it stopped sharing. Let's see. There we go. That was weird. Okay, we're back. That was weird. Let's see. So now we're going to say state internal current. And the same here. Okay, so now these are actually reactive. But now we have to, and this is fine because we're, these are all just like, the only thing we really need to be reactive from the internal state is the promise. But it doesn't matter. It's simpler to just do this. I think. Okay, let's try this version. And oh, did you see that? Now they loading for a second. Boop. There they are. Nice. Beautiful. And where are we? Now we can try to use suspense instead. Where are we? App. There we go. Okay, so now we're doing this kind of thing, right? But we should also be able to say yeah. So this would be like list or to-dos, I guess. So we can do use to-dos. Oh, sorry, not to-dos. List. To-dos query promise, right? And we can remove all of this stuff. Well, let's just keep this one, right? Because now we're gonna depend on this suspense. Let's call it suspense loading. And we can remove all of this stuff. And we would need an arrow boundary as well here for the, let's see. Then we just have list. Let's see, is this working? Called on incompatible receiver. I think this is because of the read-only proxy. I'm gonna try first to just remove the read-only thing, just see what happens. Yeah, so it worked. So that was just, well, that's really cool, right? So you can choose to just do to-do so query.state, or you can use the to-do so query.promise. And then, yeah, we need to try to revalidate. Let's see, button revalidate. On click would be to-do query.revalidate. And then refetch. Fetch. So revalidate, what we can do is whenever we fetch, yeah, let's just add a timestamp to them. Cool. We're gonna fix that read-only proxy. But first, let's test this thing. So we're getting suspense loading. We loaded the data. And if I revalidate, it should take a second without anything changing. And then we should just see it update. Oh, that didn't work. Oh, it's because we... Oh, yeah. No, this is fudge. It's because we update the promise. So I think, no, we're not updating the promise. Oh, it's because we replaced the whole internal. We can't do that. The reason it happens is because we are replacing the whole internal object, and our promise getter is looking at state.internal.promise. So when we replace internal, it's gonna replace promise. So this getter is gonna be updated. I think there is a way to... Yeah, this is interesting. So there are two things we can do here. One thing is basically not update. Yeah, but maybe that's fine. Maybe we just don't update anything. We just execute the query. And when we execute the query, it's gonna update the promise. Yeah, I think that's actually fine. Let's just do that. Okay, so suspense loading, revalidate, nothing happens. Boop! That's really cool, right? Well, the thing we do need to update is that we are revalidating. But if I do refetch, boop, it goes into loading again, and we have a new one. That's really cool. Super cool. The only thing is that it's revalidating. We need to set that. So I think we can just say query state, query state. This is state query is revalidating true. Yeah, we can do that. That's fine. Cool. Yeah, this is really awesome. This is really, really awesome. And it's like, again, it's to some degree reinventing, but it's necessary. And it's kind of cool to have like, so I really liked it. Like Mobx is very old, right? It came out when React still had like create component, I believe, like way back when. And then with class components and everything. But Mobx has never been like reiterated from the perspective of functional components and React query and all these innovations that's happened in React. So we kind of, and I'm not saying that like the old Mobx model is bad. Like it's still very good, and it solves the fundamental problem. But it's very interesting to imagine Mobx as not having classes, but having functions and having these like primitives, the concept of query and the concept of mutation. Okay, so we have the structural sharing thing. Structural, not literally structural sharing, but we have to update the data we get back. So that's going to be very interesting, because this is going to be even more optimal, right? So if you fetch, you revalidate, and there's like one property that changed on one to do, it's literally only going to change that one property. So the only component consuming that property is going to change. So that's going to be really, really amazing. We don't have to change the array reference. We don't have to change the object references. It's going to be really, really cool. Well, of course, unless we add or remove an item. But yeah, we don't have to think about that. But I don't want to do that now. That's like a type of optimization thing. It's going to be a lot more fun looking at the mutation. Oh, did I already start it? Okay, I think we need to do the same. Yeah, let's just copy what we did here. Let's see. And then we're going to try the mutation as well. Yeah, we're going to stick through this because this is too interesting. So we also have a promise here. But this doesn't need to be a suspense promise. Like we don't care about the promise in React on a mutation. Like that would be really weird to like use a mutation promise and throw to suspense. That doesn't make any sense. But we still want to have the promise because we want to be able to return it. For example, when you call the mutation from your state management, you might want to await the mutation, right? So we still want to have a sense of a promise. Yeah, and it's going to move between idle and active more. That's also a difference. And there's no revalidating, but there's a pending, there's a resolved. Yeah, but now we're also going to actually expose a pending state. Status pending. And then we're not only going to have t, we're also going to have these params. So a mutation has idle. Let's call it p extends params. And during pending, it's actually going to have params. And then when it's resolved, you get the actual value back. And then, yeah, you have the error. So this is the optimistic thing. It's the params you pass to the mutation. Let's call it mutation. P extends params. And then this is going to be promise. And then this is going to be called mutate. We're going to pass optionally the params. Well, that's the thing. I really hate this with typing. When you have, I think we can have, we need two different versions of this. So there needs to be a type mutation that has params and a type of mutation that doesn't have params. We're just going to do this. I think we can do never here. Let's just do never. Mutation with params. And then we're gonna return like multiple functions here. So we're gonna have one that has params. That's gonna return mutation with params, pt. And then we're gonna have another one which doesn't have params. And that's going to be just the mutation. And then this is going to be can I do this? No, that doesn't make any sense. Maybe I have to flip them around. No, it's not happy about this. Why are you not happy? I guess we want to do p equals never or something. Can do this, params. No, that's interesting. Oh, wait a minute. Yeah, I hate this kind of typing. I always get stuck on this. It's very annoying. But I think, can I just do this? Yeah, but then this doesn't. Ugh! Or can I put params as just never? Like make them equal to never. Okay, let's try that. Mutation. Let's put params after it. And then we're gonna say mutation t param p extends params equals never. And then we're gonna do this. Yeah. So if I do, oh sorry, so this is gonna return a mutation TP. Oh yeah, it's just SNA. So if I call test mutation, oh, this is of course going to be promise of T. Fetcher. Oh, let's do this. Turn promise dot resolve. Boop. Okay, so if I have test now, I have mutate. Yeah, but I can't call it, right? That's the problem. What if I do void? Yeah. And this is the problem, because now it expects to get an argument there. I really hate this. There has to be two signatures for this. Oh, God damn it. This is so annoying. So there is one mutation that doesn't have any. And then there's one that has params. But now this one doesn't fit. Right? Now there's... God damn it, I hate this. Yeah, wait, I had Copilot. So I am struggling with this typing. I want to create a function that optionally takes params. Mutation function. But I cannot get that typing to work. Please help. Yeah, this has always been a struggle for me, and I never remember Oh, it didn't with params. Okay, without. What did it do here? Yeah, handles both cases. It even implemented the whole thing. That's interesting. Yeah, I wonder. Yeah, we're gonna check the. Okay, but this is good. How did it handle it? Because it's equal object, and then yeah, maybe that's fine. Like, yeah, whatever. This is always a struggle. I don't care. Okay, so we have mutate, and yeah, you know what? We're just gonna try it. I'm like super curious about this. Let's just build it. That's funny. And then we have here, we're gonna do. Okay, so the thing is, we need to have. Let's call it next to this data. Next to this data. Yeah, and we're gonna, let's see. We're rather gonna just map over it and add the map data date now. I'm not sure why you are complaining so much. Unreachable code? Why are you unreachable? Why are you unreachable? You're not unreachable. Oh, of course, it's unreachable. Let. You're gonna be let. Trust me. Okay, so we're gonna next to do's data push to do, and then so we're gonna call this add reactive.mutation add. Yeah, and this needs to be async. Yeah, and it needs to return like the added to do. Oh, what's wrong here? Oh yeah. Add title. It needs to be an object. I told it that it has to be an object so that you always have like params. So let's honor that, and then we're gonna return this. Now the thing is, when I run this mutation, we want to revalidate, right? And we want to revalidate before before we return. So I'm just going to say await to do query revalidate. Cool. Okay, this is exciting. So let's add input type. I haven't done it. What's the input type? Is it text? Oh my god, I haven't done this in ages. On change. Event, if event key. Wait, isn't there like a key code? Huh. Change event. Wait. What about the... Do I have to look at the native event key? What the hell? Shouldn't I have access to a key? Like if I hit enter. This is weird. Oh yeah, it needs to be on key down, right? On key down. If event, oops. Key, yeah, there we go. Is it like enter, like this? To-dos, add. I think I can say event, target, value. And then, okay, let's just create some local state for that. Title, set title. New title, or new to do. Set new to do equals use state. To do's, add title, new to do. And then value here is new to do. And then on change, set new to do. Great. Yeah, and then set new to do. Empty. So let's go and consume this. Let's go and consume this mutation. So we're gonna do add mutation is to-dos query. What's happening? Oh, yeah, my computer is like super add. Yeah, add state. Yeah, that's also interesting. Like I can also choose. So I don't want to. No, sorry. This is correct. Add mutation. Yeah, yeah, does that really matter? Add mutation state. Let's do this. So let's just do some simple stuff like maybe we could, well, disable doesn't really matter. Maybe we can like remove it. So add mutation state pending. Yeah, what should we do? I don't know what we should do. I guess we want to do, yeah, I know what we want to do. So add mutation state, status pending, and adding, right? Something like this. And then we can also say, oh, interesting. Adding add mutation state params title, right? So this is the whole point of optimistic updates. You just check if you have a pending mutation and then you put it somewhere that makes sense. Okay, let's try it. Oh, look at me. I was trying to pick a field name. Okay, add to do test. Okay, that didn't work. Well, let's review implementation. So when calling mutate, what is it actually doing here? So cancel ongoing request. That's fine. New abort controller. Oh yeah, it doesn't actually have any reactive state. Okay, so we're gonna fix this. I think we're gonna do the same thing as we did with the other one. So we're gonna have const mutation state here. And then we're gonna say reactive mutation. That's gonna be idle. Let's call this mutation. That would be a mutation. What do I call this? State. And then we have internal. Internals. Internal. I'm not sure if we need this internal state. Do we actually need it? Status here is idle. Because we're not going to do this auto thing anymore. I don't think we actually need this anymore. But at the same time, I don't really want the board controller and everything to be... Yeah, the thing I think we can change here is that we can have an actual internal state, but we're going to make our actual mutation state reactive. Yeah, and then the question is, mutation state is now... Oh, interesting. Yeah, I guess this need... how do I know... Oh yeah, but I guess this is gonna work. So this is actually gonna be... No, this is gonna be the actual state, but that means... No, we're gonna do this, and then we're gonna say state, status, idle, and then we're gonna have our mutate thing. Let's see. Yeah. Is there something missing here? Oh, the promise. Yeah, but we don't want the promise here. Was that here? Yeah, we don't want the promise here. We don't care about the promise. So this is the mutation state that we want to return. And then we're going to move all this stuff down. Let's see. Let's clean this up. So we're going to call this function mutate. Not sure why I had that stuff. Okay, cool. So we have mutation state. We have our internal state. If the internal state is active, we're going to abort. Yeah, but that could also... Okay, we need to flip that one as well. And then we're going to say mutation state. So it's pending. We have our params. We create our promise. We update our internal state as well with the promise. And then let's see. Why do we do this? That's weird. We should be able to call it. And then, yeah, we don't need this stuff. Then, yeah, this is interesting. So this is value. If a board controller signal aborted, we're not going to throw an error. We're just going to return a value. And then, yeah, we're just going to change this thing. So mutation state, and then we're going to say that we're idle. That's fine. Yes. So there is one thing here. It's like, what if you start a mutation from React, and then for some reason you kind of want to, after that, want to await it inside your state management? That doesn't make any sense, I think. You only want to await the promise if you actually call mutate from inside your state management. Okay, and then we have the catch. But I think we have to do promise.catch. This is just to avoid browser throwing unhandled promise. Because we expect you to handle that in React, right? So if something goes wrong with the mutation, we expect you to, it's React that's going to handle that. So you might run a mutation where the promise is never caught. And then this is catch. Oh. Error again. If a board controller. So here we actually want to throw error. But here we want to, yeah, I guess we can throw it regardless. Yeah, we have to throw it regardless. Yeah. Rejected. Cool. I think this is it. And then we're just going to return our promise from mutate. Cool. Let's try it. Okay. Test. What? It didn't work. Why didn't it work? So we have this reactive state. And why didn't that work? So we're calling mutate. We're changing the state to pending, and we're adding the params. So why didn't you work? Let's see. Where are we? Beat demo. Oh, I'm hungry. Yeah, we can just do. Oh, yeah, okay. Console.log and mutation state. Does it even change? Ugh. Yeah, it did change depending. Oh, wait a minute. Is it because it's so fast? Or no, it can't be that. Why didn't it render it? Add mutation state. What is it called? 2JS or something? Let's just do JSON stringify. Okay, idle, test, pending. Why didn't it show it? Test. Oh, it immediately goes to resolved. That was the thing. Oh, interesting. Okay, so there's definitely a bug here. Why did it immediately go to resolved? That is interesting. So I'm calling mutator, but this shouldn't have a value until we have revalidated, and that should take a second. That's weird. It's almost like this promise here. It isn't waiting. Maybe it's a bug in the query, like the revalidate promise. It seems like the revalidate promise is not. So if I revalidate, I execute the query. Oh, I know what I need to do. Internal. Yeah, sorry. Return those promise. This is the promise I need to return. So even though I don't update the internal state, I want to return the promise of the new state that I will eventually update. Oh my god, everything's so slow. Not sure what's happening here. Adding, boop. Well, that was a bit weird. But we can like change that so it looks a little bit better. Where is it? To-dos. So we can unshift it instead. Then let's see. Suspense loading, test, boop. Look at that. And that's how you do optimistic updates. Nice! This is really awesome. So I need some food. I'm super hungry and I have some stuff I need to do today. So I'm gonna do that. And then we're gonna add the actual check. So when you return some new data, we're gonna do a check, optimal updates. So for example, if we toggle a to-do and we send that to the server and we revalidate with the server, then we're only gonna update the to-do that actually toggled. Well, it's kind of interesting because yeah, I'm having a hard time with this revalidate thing. Like it's simple, but like what if you want to toggle a to-do and then you like toggle another one and then you fetch all the to-dos twice just because you toggled? Yeah, but it is like simpler, I guess. Anyways. Yeah, this is really cool. And just the simplicity of like consuming all this stuff, it's pretty amazing. One thing that we no, that doesn't matter. I guess one thing to consider here is like the mutation. It moves into like a resolved state, and it will stay there until you actually try to mutate again. The same with like rejected. Yeah, and maybe in rejected you can still have the params, I think. Yeah, should still have the params there. Params? Yeah. Like the question is there really a resolved state, or should it just move back to idle? That's a question. It's nice to have resolve though. Like you want to actually highlight that you added something. Maybe you can reset the mutation or something. I don't know. Anyways, that's it for now. Let's just build that last change. But I consider this like this actually works now. So this is super nice. Git commit queries and mutations. So what I'm gonna do is I'm gonna take these reflections, I'm gonna get them into like the actual readme here in a way that makes sense. And focus on, like I'm calling it server driven, client driven. It's fused state with UI. And here we have separate state from UI. I like that. I don't know to what extent we need to explain it. Oh, read only. Okay, let's do a quick look on the read only thing. Reactive read only. I think it needs to be fixed. Yeah. Yeah. I think we just have to check if it is a promise, and if it's a promise, we're just gonna return. Where did the code go? Read only. So I'm not sure what the best check here is. Yeah, let's ask ChatGPT. How do I best check if an object is a class? Like generic check for if it is a promise, map, or whatever. I guess there's this package called isPlaneObject we could use, but we don't want to actually check if it's a plain object. We kind of want to do the opposite, because what we're doing is that we're creating a proxy around the promise. But we don't need to do that. We only need to do that for actual plain objects and arrays. Yeah, because here I have this very simple, like if target is null or not an object. So this moves down to like, yeah, wrapping the, what is happening with my, everything is taking so much time. Like a simple fix here will be like target instance of promise, right? Yeah. Yeah, let's do that for now. Do not read only proxy. Oh, there's a one size fits all is class. Oh, interesting. Yeah, particular class. Yeah, so if it's like not an object, like if it's not object, yeah, Yeah, exactly. Yeah, I like that. Okay, we don't have to do that now. I need some food and do some other work. But it was super fun. I'm dreaming about like doing this presentation of like modern Mobx kind of thing. As I mentioned, like Mobx is very old, and I got inspired when we got that PR approved for adding the observers. So actually having automatic observation part of Mobx documentation, and then it's almost like invigorating Mobx. Is that the term? Because it is a really, really good solution, and it's so battle tested, and it's been so useful. But it's kind of like this old uncle in the corner these days. Okay, thanks, Adam. But yeah, it would be really cool to do something there. And then as part of that, like talk about how the mental model that we're talking about, like separating the UI tree from the state tree, and then how with Mobx that has kind of created a bigger shift. Like you're flipping not only between these two trees, you're also flipping between two paradigms. One thing is mutable, which is oh, I think that's, yeah, the console log is just from the Vite demo. That's fine. But yeah, there is this cost of like working with immutable state in React, immutable state in your state management. But there's also been this cost of working with functional components and object-oriented classes in state management. And that doesn't have to be like that. You can have functional state management and functional components. And then for data management, it's been very manual, but now you can like, you have query and mutation, you can use suspense, and it's all kind of built in. Yeah. That'll be kind of cool. Anyways, thanks for following along. We'll speak soon. Bye.